All right, 12-2 goes over conditional probability. So it's taking probability even a little further. So there's a concept box here. Remember, you can always access this notebook in our Canvas class notebook. So if you want to see the notes later, you can open it there. We have a little bit of new notation. So remember, mathematicians are lazy. They don't want to actually write full sentences. So they have notation to say it. So the notation that is right there says probability B given A. And what that means, I put it in words, probability, so that P is probability of B given, so that straight bar is the word given A. So that just makes it so that they don't have to write so much but still know what they're talking about. So when would I use this? Well, when we have tables is often the most, is when we will most often use them. So what is the probability that a member of the drama club is a sophomore? So here's what we're wanting to find. Probability sophomore given drama. So that means that we're picking someone from the drama club. We know it's going to be one of those people from the drama club. So if my table had not had totals, the first thing I would have done is made totals. Okay, so luckily that saves us a step. They already did it for us. Yay. So the bottom here is the total. So we want total for drama. So total for drama is 17. Of that total, how many of them are sophomores? Well, 3 of them. So my probability is 3/17. Okay, so remember, to switch to a decimal, you would do 3 divided by 17. If we wanted the percentage, we would multiply decimal by 100. So that's just percentage, fraction, decimal forms that you should already know, but if you forgot, that's okay. There's your note. All right, let's look at what B says. It says, what is the probability that a sophomore is a member of the drama club if we have probability of drama given sophomore? So this time we're given the sophomore, and we want to know how many is drama. Well, there are 36 total sophomores, and of those, 3 of them are in drama. So it says, is the probability of sophomore given drama the same as the probability of drama given sophomore? Well, no. You're pulling from different groups. Well, the most obvious answer is no, because we got 3/17 for the first example and 3/36 for the second example. So they're not the same. But it's because up here we were pulling from all the drama people. For this example, we were pulling from all the sophomores. So you're talking about a different group of people. So that gives us a different probability. All right, to understand whether something is independent or dependent, we have to know this little piece of information here. If the probability of B given A is equal to the probability of B, they're independent. If they're not equal, then they're going to be dependent. So let's look here. It's talking about vehicles in a parking garage, and we got this big table of all the colors and the types and the total. We want to know whether, if a vehicle is black and the vehicle is a van, are they independent or dependent? Well, if I look at the probability of a van, given that it's black, so I know that it's going to be one of the 13 vehicles that are black. 3 of those vehicles are vans. Okay. What if I just want to know the probability of a van? Okay. So there are 3 vans out of a total of 22 cars. Now notice these are not equal, right? So 3/13 is not the same thing as 3/22. Yeah. So therefore I can say that these are dependent because probability of V given B does not equal the probability of V. All right, example 3. We want to apply the conditional probability formula. Okay, so we need to know that the probability of B given A is equal to the probability of A and B divided by the probability of A. Or if I rearrange that to get the and statement by itself, I would multiply both sides by probability of A. So same formula, just finding a different thing, right? So here we have a band's marketing agent is conducting a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? Okay. So we're going to use the probability of A and B, because that's what we want to find. It says, what is the probability of the band's concert and is a fan of the group? And so in order to do that, we need probability of B given A times probability of A. Okay. In this case, we're going to let B be equal to a fan and A equal to attending. Okay. All right, so if we look up here, it says there's 70% plans to attend. So under probability of A, we're going to put 0.7. All right, so you're like, Ms. Reidner, how did you get 0.7? Well, if I have a percentage, I can take the percent divided by 100 to get the decimal. And so 70 divided by 100 is 0.07, or 0.7, if I could say that in the right order. Okay. We also want to know the probability of the fan given that they attended. You have 80% of students who plan to attend and they are fans of the band. So that is your given. And we need to multiply those together. Again, 80 divided by 100 is 0.8. If I multiply those together, I get 0.56. Okay. If I want that as a percentage, I multiply and get 56%. Last but not least, I'm not even going to finish this one, but I'm going to do the first one and leave the rest for you guys to do. It says a marketer is looking at mobile phone statistics. A marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find out which of her company's products is most likely to be purchased after a search for that product on a mobile phone. Okay, so that means that we want the probability of buying given that we searched it. Well, if we scroll back up here and look at our formula there, it is equal to probability of A and S divided by probability of A, or in this case B. Sorry, it has to be S because it's B given S. So divided by probability of S. So I'm going to do it for W and leave the others for you to do. So W, we look there. Search and buy is 16%. So that's 0.16. Divided by just the probability of search is 0.46. 0.46. Calculate that. We get approximately, I'm going to round, 0.348, or times that by 100 and get 34.8%. Okay. So for X, Y, and Z, see if after this video stops, you can get the answers 43.75%, 34.3%, and 37.5%. And that's the end of notes.